Hey everyone, welcome to Code Harmony. Today we are solving a easy question based on hash table, which is LeetCode 1935. Maximum number of words you can type. Let's have a look on the problem statement. There is a malfunctioning keyboard where some keys, letter keys do not work. All the other keys on the keyboard work properly. Okay, so some kind of story that we have a malfunctioning keyboard where some letter keys does not work. And we are given a string text of words separated by a single space, no leading or tailing space, and a string broken letters of all distinct letter keys that are broken. Written the number of words in the text that we can fully type using this keyboard. Okay, so we are having a keyboard where some letter keys does not work and all the other keys works properly. And we are also given a string text, and this text in such a way that we have couple of words, word 1, word 2, word 3, and maybe let's say word 4, and these words are separated by just one space and there is no leading or tailing space. It means initially and at the starting, at the ending, there is no space, so it's well structured. So this text is given to us, and we are also given broken letters. It means these letters are the letters which do not work properly and we are not able to type these letters. And they are asking us how many number of words we can type properly. We can fully type. It means all the letters of that word we should be able to type. This is our problem statement. If I just do the dry run over this given input, we have a text. This text is having number of words separated by a single space. Yes, we can see that word 1, word 2 separated by a single space, and there is no leading and tailing space. And broken letters. It means on my keyboard, letter A and letter D I cannot type. And I have to tell the caller that how many words I can type properly. Can I type this word? Yes, if I am able to type every single character from this word, I will be able to type this word. If I am able to type every single character from this word, world, we can type that. Okay, so in this case, what is going to be the answer? See, A I cannot type, D I cannot type. This complete word I can type because there is no default, no like broken word in this, broken letter in this word. Let's have a look on the second word. Second word is WORLD, D. See, D is something that we cannot type from our keyboard. So this word is not going to be counted, and we are going to have only one word that we can type, which is hello. So 1 is our answer. So 1 we have to return. So this is our problem statement, and now let's see how we can do it. Let's also have a look on the constraints. In the constraints, they are saying that the text length is going to till 10 power 4. And broken letters less than equal to 26. Maybe they are only considering lowercase English letters. Text consists of words separated by a single space without leading or tailing spaces, and each word only contain lowercase English letters. So that's why maximum 26 letters we can have. Broken letters consist of distinct lowercase English letters. So it means already distinct. It means there is not something like, or in short, the broken letters length is definitely less than equal to 26 because they are just telling us the set of letters, not just letters multiple times that A cannot type, A cannot type, A cannot type. Okay, so let's have a look on the approach, how we can do it. See, we just have to go with the brute force in this case. And what is our brute force? We will check every single word one by one and we will see whether we can type that word properly or not. And how we can type that word? We have to iterate over that word using this. So first of all, what I can do is to make our problem simple, as there is no leading and tailing 0 and only one space is there, I can split the text string by single space. If I split the text string by single space, what I'm going to get? I'm going to get hello and word, these two words. Words array. What is that? String array. So this is the first step I did. And after that, I can check for every single word whether the word is containing any broken letter or not. So for those broken letter, it is a string. There is no need of taking a string. Let's take a set, because we want constant time lookup. Let's say this is A and this is D. So if I'm taking a set, I can directly say that, okay, whether this character is broken or not. So set of size maximum of 26. So let's say we have converted it into a set. And this is the word. So what I will do is I will run a loop over the words and I will pick every single word. And when I'm picking this word, I will compare every single character one by one to the broken set. So let's say I'm picking HELLO. Hello. I will see for the first word, first letter H. Whether H is broken or not. No, it is not broken. E is not broken. L is not broken. L is not broken. O is not broken. We have traversed over this word and there is no broken letter. It means yes, we can type it. So count is equal to 1. Okay. So now what is the next word? Next word is world. In this world, can we type W? Yes. Can we type O? Yes. Can we type R? Yes. Can we type L? Can we type D? No, we cannot type D. If we cannot type a word, type a letter, if we have encountered a broken letter, at that time we just have to break this loop. Just break this loop and just capture that, okay, we cannot type this word. So what I have to do is, let's say when I'm iterating over the whole word, we are not capturing anything. Let's capture the cases where we are not able to type a word. So here at this moment, we have encountered a word which is belonging to this set. So this D belong to this set. It means that can't type word plus plus, or you can say a simple kind of counter plus plus. And at the end, we already know number of words. Number of words are n minus count. This is the number of words we can type properly. So what I just did here is, first of all, I utilized the benefit of string operations, splitting the string into words. So string array I just took, and after that I iterated over that array and checked for every single word. For every single word, what I did is I converted that string to a character array and iterated over that using for each loop. I can do that, or whatever approach you are going to pick, you just pick that. Character array I just took and iterated over the word, and for every single character, let's say for every single character CH, I just checked whether the set contains. If set contains character, then just break it and can't type word plus plus. We cannot type that word. So this is something we can do, and let's have a look on the code. Now before that, let's also discuss the time and space complexity of this approach. Space complexity is we are taking an extra space which can go till 26, so we are not going to count that. And this text length is 10 power 4. So first of all, we'll just split that. Maybe the splitting is going to take order of n time. And then I will iterating over every single word. That is a parallel operation, not a nested operation. So that is also order of n time. So overall, it is a linear time. So it's a linear time operation, and let's have a look on the code now. I took a set, and in this set, I'm going to add every single broken letter. So for every character from broken letters dot to character array, I'm just going to add that into the set dot add ch. After that, split the text string array words text dot split by a single space. Here we have a list of words. So for every single word in words, we will do something, or we will do the iteration. what's that iteration? For character ch word dot 2 character array. Word dot 2 character array ch if set dot contains. Set dot contains that, like that broken letter. If set contains that broken letter, what do we have to do? We just have to break it, because if this word we cannot type, we don't have to explore further. And before that, just capture it, count plus plus, and count is going to contain the count of words that I cannot type. Int count is equal to 0, count plus plus, and in the end return words dot length minus count. Let's see if it is working fine, or do we have any compilation error? Yes, we have a compilation error. Words is equal to text dot split. Let me run it again. Set characters, कहाँ से आ गया? Character, set of character, set, and then added on all the broken letters and iterated over every single word, and the checked the words that we cannot type, and total number of words minus words we cannot type is equal to words we can type. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. Do let me know in case you have any doubt, and it's a easy beginner friendly problem for a topic of hash table or string, you can say. Thanks for watching guys. Bye bye.